Okay, thank you. So, good evening, everyone. So, in today's session, we're going to continue the SLT topic. So, just to give a 5 minutes recap on the last week's session. So, in the last week, basically, we have seen SLT comes in two versions. One is 1.0 and 2.0. You can know the version of SLT by looking at the DIMS, DMIS. If a source system is an ECC source system, when you connect to SLT is an RFC connection. When the source system is a non-SAP, you connect via DB connection, and SLT connect to HANA via DB connection. SLT can be installed as a separate host or it can be on the ECC side. Whether it is ECC or whether it is a separate host, you need to have an RFC connection. Also, we try to see the roles that an HANA admin has to perform and the application consultant has to perform. So just to give a brief overview of the admin. So admin has to create an RFC connection between the SAP system and SLT. He creates this in a transaction code SM59. So once the RFC is created, once the RFC is done, he creates a configuration in the T code LTRC where he specifies what is the source system, what is the target, how many job servers you need to utilize for data transfer, how many jobs for full load, initial load. So once he specifies and create a configuration with the same name as configuration, a schema is generated in HANA system. So under the schema, initially tables like DD0, 2L, 2T and 8L are replicated in HANA system. With the status, replicate in process. So until here, we just discussed theoretically, but we haven't seen anything practically. So in today's session, we mainly focus on doing the practical. So first, I'll start with showing you the various connections that is already configured by the HANA admin. So let us go to ECC. Let's go to SAP logon. Let me show you step-by-step process. Let us see step-by-step process on how this configuration is created. So first let's go to ECC. Let's provide the username and password. The username is Surya. Password S capital URYA 1234. Enter. Go to the transaction code SM59 and click enter. So once you click enter, so let me just draw a diagram. So in here you have ECC, SLT and HANA. So we're creating an RFC connection between ECC and SLT. So at the ECC, creating an RFC connection at the T code SM59. We're creating an RFC connection, SM59. So let's go on to the ECC. So there's an ABAP connections over here. This configuration is done by admin guys, but for us it is good to know. Let's go and see, check the RFC connection. So here you have different RFCs. So let's check RFC underscore SLT. Double click on the connection. Double click on the connection and click test connection, connection test. So once you click connection test, it's pinging the connection. So once the connection is tested, so we're going to use this connection, which is RFC underscore SLT. So this is the name of the connection. So we're going to use this connection when we create a configuration in the LTRC transaction code. So let's go to LTRC transaction code. Let's come back and enter the T code LTRC and click enter. LT replication server cockpit. LTRC means LT replication server cockpit. So here you see selection of mass transfer ID. So what is a mass transfer ID? The mass transfer ID is an ID that is generated for every configuration that is created. The configuration is uniquely identified by the mass transfer ID. So let me enter a configuration 047. So this is the ID for a configuration which is already created. Click on create new configuration. So once you select the configuration and click details. So please see what is the name of the configuration here, SLTCC. The source system is an SAP source system. Then it is an RFC connection, RFC underscore SLT. So here we're giving the name and the description. So the third one is the number of data transfer jobs. There are 3 number of data transfer jobs. So these data transfer jobs will help to replicate data. And the initial load jobs will help to do the initial load, that is load. And these are replicate jobs. So these jobs, the 3 jobs that you're seeing here, you can see the jobs that are running at the transaction code SM59. So let's click on create. So I'm just trying to open another session so you can monitor the jobs that are running in the background. Click on create session. Enter the transaction code SM59, sorry, SM37. Click enter. So here you see the job name and the username. So I just want to see what are the active jobs. So I'll just uncheck everything because I would like to see only the active jobs and click execute. Once you execute, so here you see the jobs that are running in the background. Here you see there are 4 jobs. One is the master job. The second one is MT 007, 001, 002 and 003. These 3 are the data transfer jobs. This is the mass transfer ID 047 is the mass transfer ID, and these are the data transfer jobs that are continuously active. These jobs continuously look for any changes in the source and then transfer data to the target system. So the number of jobs that you specify here, each job can transfer 4 tables. Each job requires 0.5 CPU. Let's say for our requirement we require 16 tables, then we require 4 jobs. One job require 0.5 CPU. Usually if you see in the project SLT systems, there are small scale systems, there are medium scale and large scale. If you see a small scale system, it has 8 GB of memory, 4 core CPU. Medium scale, you could see 16 GB, 8 core CPU, and large scale 16 to 64 GB of memory, and you could see 16 to 32 core CPU. So it depends on how many tables you're replicating to HANA system. So based on that, we do the sizing that is done by the HANA administrators. So once you provide the data transfer jobs, so already the connection that we created in SM59 is RFC underscore SLT. So let's go back. So we already taken, so we can just select here the RFC. The admin selects the RFC connection, and here you find the RFC underscore SLT. So this is the source system. If the target system is HANA, then it is a DB connection. So admin also specifies what is the username. This is the system user. What is the host HANA server? What is the instance? And it specifies whether it is real time or schedule. So we are taking this job as a real time. So once the configuration is created, with the same name of the configuration, let's click Start. Let's click HANA Studio. There is a schema that is generated by system that we could see in the HANA Studio. So let's go to HANA Studio and expand system, expand the catalog. Under the catalog, let us search the schema. So what is the configuration name over here? SLT ECC. Go back to HANA Studio. You would find with the same name as the configuration, SLT ECC. Now in this schema, all the tables that are relevant for SLT will be replicated. Expand the schema, expand the tables. Let me remove the filter. So all these tables belong to SLT that are already replicated. So when the schema is created based on the configuration, if you click on the data provisioning, once the schema is created, immediately there are 3 tables, DD02L, 8L, and 2T. So you can see 2L, 8L, and 2T. All these tables are replicated. Replicate in process. So once these 3 tables are replicated automatically by system, and the status is replicate in process, then the HANA admin gives us the authorization to replicate tables from ECC to HANA. So now we know in HANA there are basically 5 options. One is load, second one is replicate, third one is stop load/replicate, fourth one is suspend, and fifth one is resume. Load, replicate, load/replicate, suspend, and resume. So these are the 5 options that are available. So first let us start with to see practical for load. When do we go for load? Load is mainly for use for non-frequently changing data scenarios, especially for master data. So if you take a master data table, when we use a load option from SLT to HANA, the table is created. The table is created in HANA. The records that you have in the table will be loaded. Suppose say you have 10 records in the table. As an example, all the 10 records will be loaded. Any changes, for example, you added 11th record or you updated a 9th record, you won't get the changes unless and until you perform a load again. When you perform a load again, it deletes the previous table, creates a new table with again all the new entries. So every time when you perform a load, the previous table is dropped, it recreates a new table, and loads all the content from source to target. This is the default behavior of load. Now, in order to demonstrate this example, I'll create a custom table on the ECC side. Let me create a new custom table. I create my own table, enter few records in the table, and let us use load option. Let's go back to ECC. Go to SC11 transaction code. Click enter. Let me create a new table. Click create. I'm creating new ABAP table. So usually we don't create tables. These are created by ABAPers. But just for showing end-to-end scenario, I'm creating a table over here. But usually we don't do this. So select application table, master or transaction data. Display maintenance allowed to enter data. Click fields. I'll just create a table. So let us take like BUKRS, VKORG, UV010. So we have entered 4 columns. Let us take a key. Let us define data types. Char. This I'm creating a sample table. Let us enter data length. So once we create the table structure, click on Technical Settings, click Yes, click Local Object, click Continue. All these are standard steps in SAP to create table. Data class, whether it is master or transaction data, you have to specify what is the size category, how many records you want to store. Once you specify, click Save, click Back, and click Activate. So once you activate, the table in ABAP is created. So just we're creating a table in the SAP system. So once we create, so usually we don't create. So once the table is created, click Utilities, Table Contents. Let's create few entries in the table. To have more control over the data, I'm creating a custom table. Let me enter a few records. Let me click Save. Table, a database record successfully created. So a table, and if you click Back, click Contents, and click Execute. So here we created a table and we created one record over here. So what we will do now, let's use this table. Let me use this table, which is just use this table, and I'm going to use this table to transfer to HANA using SLT. So in order to transfer to HANA, as you know, there are two UIs. One UI at the LTRC and the other UI you have at HANA Studio. So let's go to LTRC transaction code, or you can go to HANA Studio data provisioning. So let's go to LTRC transaction code on the SLT server. Let me go back. So let me come to the initial screen of SAP, click back, and enter LTRC, click enter, mass transfer ID 047. Mass transfer ID we don't create, this is created by the system automatically based on the configuration, and click execute. Once you execute, so here you see the tables that are already replicating 2L, 2T, 8L. So few tables have been loaded, TSPA, TSPAT. So now I am going to load my table, the table I just created. Click on data provisioning. Here you have start load. Provide the technical name of the table, copy paste, and click execute. But before I execute, let me go to the HANA Studio. So once you execute, the table will be available in the SLT ECC schema. If you want to monitor the load at the quick launch, click on the data provisioning. Click on the data provisioning. So you can, this is the monitor where you can see the status of the loading process of the tables. So if you go to tables, Let me right click on the table. Let me filter and give the table name, whole word. Click OK. So do we see any table over here? Still the table is not loaded. That's why we don't see. Let me go back to LTRC and click start load and click execute. Once you click execute, one table scheduled with action start load. Let's go back to HANA Studio and click refresh over here on the top. Once you click refresh and click come to extreme bottom, and then here you see the table ZMTB underscore SLT. The action is load and the status is scheduled. Means that the table is being loaded to HANA. So the final status that you should see here is load executed. So let's refresh. So the table is still being loaded. In meanwhile, let us right click on the folder and click refresh. The table is being created. Let me right click on the table and click open content to check whether data is loaded. The data is loaded. One record we created on the ECC, the table and the record has been transferred to HANA. Let's come back to the second tab again, data provisioning editor, and click refresh. So finally load executed. The status of the load is executed. So once this is done, status of the load executed. Let's come back to LTRC. Now please see when you refresh over here, the current action is load but no replication. So do you see any logging table created or any status trigger is being activated? No. So no logging tables, no DB triggers, only load has been done. So let me go back to the table on the ECC. Let's go back to the base table. S11, enter. Click display, click contents, and click execute. Let me create one more record. I'll create one more record. And click save. Click back. So we have two records now. So I'm also going to change the first record, VV070 from 22. Say I'm going to change to 40. And click save. The first record I change, I've done an update for the first record, and the second record I've created new. If you go to HANA, if you check the table, now this is HANA and this is ECC. If I do refresh, now please see, do any change that we see here? No, because load is only one time. Any updates or any inserts that you make on the source table will not be reflected. So in such a situation, the only thing that we can do is load the table again. So let's go back to LTRC. Let's go back to LTRC. Click data provisioning again. Start load and execute. So every time any changes are made to the base table, if you go to HANA, now let's refresh. Click refresh. Please see the table is dropped. Invalid table name. The table is dropped. Click refresh again. Table is dropped. So every time it will drop the table. Again, please see, it creates a structure again. It creates a structure again and loads the data. Now if you see the data, ECC and HANA both have the same data. So what is the major disadvantage of load is any changes made to the base table, in order to get the records, the default behavior, it will drop, recreate new table and load all the data. So in this case we only have 2 records. Let's say you have a million records. In a million records there is only one change. So in order to bring that change, you need to drop the entire 1 million records, reload the data. So it is very time consuming because every time it deletes and reloads takes a lot of time. That is the major disadvantage of load option. Only one time load. Now if you do the same process with replicate, let us do the same process with replicate. The table is created, entries are loaded, changes are not loaded unless and until you create the table again, the changes are available. Now when you do the same option with replicate, what replicate does is, let me show you. So what replicate does is, you have source, SLT, HANA. Let me make this diagram a little larger. So what replicate does is, whenever you use replicate option, the system creates logging table and DB triggers are active. So first let us see this. We'll load the same table again. The name of the table, so this is the name of the table. So we'll load the same table again. So whenever you replicate a table which is already replicated in HANA, when we change from load to replicate, so now it is in load. When you change the load to replicate, so what replicate does for the first time, first it doesn't create logging table or DB triggers. As if it is doing load, it does load. It drops the table again. The first, when you do a replicate, again it does load and then replicate. So first the table is loaded. Whatever the entries in the table are loaded. Then the status of the table is load executed. So first it does initial load. So once the initial load is complete, then second step, it creates DB triggers and logging tables. Once the DB triggers and logging tables are created and active, from then onwards, any changes to the existing data or any newly created records are transferred or identified by DB triggers. DB trigger is nothing but a piece of procedural code that monitors for any events that takes place on table and forwards to logging table, read module will read from logging table and write to HANA system. So let us see this. Let's go back to LTRC. So the status of the table now is currently load table. Still no logging tables, no DB triggers activated. Click on data provisioning. Click start replication. Click execute. So once you execute, one table's scheduled with action start replication. Click refresh. Let's see in HANA. Click refresh here. Please see. It dropped the table again. Click refresh again. The new table is created again. Let's see the progress of the job. Data provisioning editor. Click refresh. Please see. Load executed. Again the status is load executed. When load executed, it's only loading the data. Come back to table. Click refresh. Please see it loaded the data. Again go to data provisioning editor. Now meanwhile what system does in LTRC, let us refresh over here. Refresh. Please see it created logging table and DB trigger activated. Once the logging table and DB trigger is activated, the status of load to execute should change to replicate in process. So let's refresh. Please see it changed to replicate in process. So once it changed replicate in process, now any changes that are made to the base table, let me go make a change. Let me go to ECC. So 1000, here it is 40. Let me delete 40 and enter 80. Save. Come back. Let me create one more entry. Create with template. I'll just change this to 3000. And click save. Come back. So this time I made a change to the first record 1000 and I created a second record 3000. Immediately I go to HANA. Just refresh. Please see in real time the data is updated. For 1000 it updated 80 and 3000 record has been created. So real time transfer of data. So in this case, who is identifying the change? DB trigger is identifying the change and moving to logging. The data from logging is read by read module and sent to HANA by using write modules. In this way, whenever the user is trying to do any reporting, open data preview. Let's say he's trying to do some analysis. BUKRS. Let me drag and drop to labels axis. VV010 into values axis. So let's say user is trying to do reporting. And if any changes are occurring on the source system, let me go to ECC. Let me delete entry. I'll delete the 3000 entry. I'm deleting this entry. Click delete entry. Click back. Come back to HANA. Click refresh. The entry is deleted. Only two records, 1000 and 2000. 3000 is deleted. So in real time, the data will be transferred from ECC to HANA. So that is the importance of replicate. So replicate, when it is replicate in process, the jobs that are running in SM37, create session. In SM37, there are few jobs that are running in the background. So these jobs are data transfer jobs. These jobs are data transfer jobs that are basically replicating the data from ECC to HANA. So the other options that you have, so we see load, replicate. In the replicate option, if you go to LTRC, here you see logging table. The naming convention of the logging table is 1CADMC /00000628. Always this logging table is attached to the base table. If you want to see the logging table, copy the naming, Control C copy, create session, go to SE11, enter, provide the table name, click display. So this is the structure of the logging table. Click contents at the logging table. So this is an above table that is created. Click number of entries. The number of entries are 0. So there are no entries in the logging table. So when do we get entries in the logging table? When we get entries in logging table, when we use an option called suspend. So when you use an option called suspend, the read modules will not be allowed to read data from logging table. Now why we have to suspend? In case, let's say, there is a scheduled downtime on HANA. The restart of HANA is required. So if you don't suspend tables that are being replicated, continuously the data is sent to HANA. But HANA is not in a position to receive. So data records are lost. The changes are lost because HANA is down. So that's why whenever you have a scheduled downtime, you can temporarily stop data using a suspend option. So let me go back to LTRC. So you have the table that is being replication status. Click on data provisioning. I'll click on suspend option. Click execute. So before I execute, let us go to HANA Studio. So what is the status that you see here? Replicate in process. When you use a suspend option, whenever you use an option called suspend, the status of the replication will be temporary halt. So you get action suspend, status executed. So the status will change to suspend executed. Let me go back to LTRC, suspend replication, click execute. Tables scheduled with action suspend replication, and click refresh. If you go back to HANA Studio now, let's refresh here. Please see the status suspend executed. It means that any changes that you make on the ECC, let's go to the ECC. Let's make any change over here. Let me update 80 to 60. Click save. So what I've done an update. Let me create a new entry. Create with template. And click save. I created a new entry with 800. So one, I've done an update from 80 to 60. And second, I have created a new record. So let me go back to HANA now and check whether any changes in the table. So please see, this is the previous data, 2000 and 1000. For 1000 previously it was 80, now I updated to 60. Now 60, if I refresh, it doesn't change. Please see, there are no changes to the records because we suspended. Now when we suspend, where will the data records present? The data records will be present in the logging table. What is the naming of the logging table? We can find in LTRC. So this is the logging table. So we already opened this logging table in S11. Please see, we already opened. And already we checked the logging table 628 has the number of records 0. This is before suspend. But after suspend, if I see the number of entries, how many entries we have? 2 entries. Click close and click execute. So one is an insert. 800 I've done an insert, and for 1000 I change from 80 to 60. So whatever the changes that you've done on the base table, with the primary key, with the flag, with the timestamp, it is updated in the logging table. So temporarily the data is halted at the logging table. So once you think, we can resume. Let's go back to LTRC. So here you suspended. Click data provisioning. You see the status here at HANA under data provisioning editor. Still it is suspended. Let me resume again. Let me go back. Go to LTRC. Select resume replication and click execute. So once you execute, click refresh. Come back to HANA Studio. Here you have suspend executed. Again the status should be replicate in process. It should change now. Click refresh. It changed to replicate in process. So once it changed to replicate in process, it means that the data that is present in the logging table, when I refresh, it will be 0 now. Refresh. The entries are deleted. Now where did data go? Finally to target. Let's go to HANA. Refresh. Please see, the entries in the logging table are deleted and updated to HANA. So now let's come back and check the base table. And both the base table and HANA should be same. 40, 40, 60, 40, 40, 60, and these are the primary keys. So in this way, whenever you don't want to update data to HANA for any reason, you can just temporarily halt the process by doing suspend, and when you want, you can do resume. Now what is stop replication? Stop replication is especially used when you want to permanently stop replicating of data. When you want to permanently stop replicating of data, it means that logging tables and DB triggers are deleted. If we go to LTRC, if we move to LTRC, logging tables and DB triggers are activated now. If we click on data provisioning, and if I stop load/replicate, it will permanently stop. Suspend is temporary, stop is permanent. Click execute. Tables action with stop load. The table will be deleted from LTRC. Just refresh. Please see the entry is deleted here. And We want to find the logging table. Please see. You'll not find, but it goes to short dump because the table is no more. You can SE11, double click, find for the table, display. What does it say? Does not exist. Check name. The table is deleted. And even the DB triggers are deleted. So if you make any changes to the base table now, if you make any changes to the base table, the changes will not be updated to HANA. If you make any changes to the base table, it will not be updated to HANA system. And if you see the status, of data provisioning, replicate in process, refresh. Finally, the status is replicate executed. Means the replication is finished. So load only one time. If you want to replicate table continuously in the sidecar scenario, you can use replicate. Stop replicate, permanently stop replication process. Suspend, temporary halt. Resume, again resumes from logging tables to target system. So in this way you can use, and 99.99% SLT is a very proven technology. There is no downtime at all. It's very proven technology, continuously replicates data without downtime. So in the next session we'll see advanced replication settings. In the advanced replication settings you can basically remove unwanted columns, you can delete unwanted columns, you can change data types. All these things can be done in advanced replication settings that we'll see in the next class. So in today's session, just me recap. In today's session, we're trying to see the configuration that is done by the HANA admin. And then we're trying to see the difference between load, full, replicate, get changes, or newly records, stop, permanently stop, suspend, temporary halt, resume, replicates data from logging tables to target, and delete entries from logging tables. If you have any questions, please ask me. So one question, after stop replication, will data be present in HANA? After stop replication, data will be present. But thing is, now please see here, if I make any changes in the base table, the data will not be reflected because I stopped the replication. Suppose say I'll delete an entry in the table. If I delete an entry, the HANA table will not get reflected unless and until you re-replicate the table again. The stop is a permanent halt. Now when do we use stop is when you don't want the table anymore to HANA. You're replacing with a new table. Whatever or so. If you do not want the table to replicate data, then we can permanently stop the replication. Let's see the next questions. Let me check the next question. So when we have an option in HANA also, load, replicate, suspend, why we use on the ECC all the options. So we'll see in the next class, we'll use these options as well on the HANA. But both these options are same, both ECC and HANA are same. They do the same functionality. Why load is needed? Next question, why loaded is needed if replicate does all the initial load? Because replicate consumes more resources. Now let's say the data in the table is not frequently changing. So if you do a replicate, a job is allocated to it to continuously look for any changes, but there are no changes. So we're just trying to optimize system utilization. So based on the frequency of changing of data, for frequently not changing, we use load. For frequently changing, let's say data is changing frequently, then we can use replicate. It is not that we cannot use for master data replicate, you can use, but at the cost of system resources. So whenever you think there is a change in base table, you can do a load again. Instance is nothing but a system. Instance is nothing but a system. Can we do reporting on a table which is deleted in the source system? If the table is in HANA, you can do reporting. Because when you stop, even though you delete the table in the source system, the table in HANA will exist. Is there any prerequisite before creating a configuration and replication? So you need to make sure that SLT sizing is done. Now the SLT sizing is done based on the inputs of the application consultants. How many tables are being replicated? What is the volume of data? What is the frequency of data loading to the target? Or changing of data in the source system. So all this will be taken into consideration. And based on that, the HANA admin will do the sizing. So we need to size the jobs appropriately. So based on the tables, because if you have more tables and less jobs, the latency of data will increase. So it will take a lot of time to replicate data. So what happens if next question, what happens if replication is suspended for longer period in time? So because if you suspend for longer period, the logging tables will become full. There are chances that if logging tables become overflow, then you may lose data. That's why you need to halt data only for temporarily and then again resume. Now if you want to change, if you want to have a lot of data in logging tables, you need to change the data class. So you need to have appropriate data class so that data class will accommodate the number of records in the logging table. If you think you have a lot of data in the logging tables. So can we directly upload data from Excel to SLT? No, we cannot directly upload using Excel to XLT, but using an Excel, you can upload to HANA. You have an option called import data into HANA system.